Hello everyone, this is Mr. O'Leary with a video on solubility of ionic compounds in water. So if we look at AgNO3 and Na2S, we look at these, if it was a double replacement reaction, what would happen? Would silver bond with sodium? No, because they're both positively charged. NO3 and sulfur? No, they're both negatively charged. So there's only way, if this reaction is going to happen, there's only one way it would be able to go. Sorry for the handwriting, that was terrible. But you get the idea. It's cation with an anion in the other one. It's their double replacement. They're both replacing. Now, what we need to do is look at and see, we have silver and sulfur. So we know silver is a +1 charge. What does sulfur come up to be? Sulfur is over here. It has 6 valence electrons. It needs 2 more valence electrons. Silver can only give up 1, so it would have to be Ag2. Why? Because silver only has 1 valence electron to give sulfur. Sulfur needs 2. And we have NaNO3, and NO3 is one of our polyatomics. It's a -1 charge. Na has +1, 1 valence electron to lose. So the NaNO3 is balanced there. So if we were to look at this, we'd also have to overall balance this equation. We'd put 2 here to get 2 silver on both sides. Now we have 2 NO3. We need to get 2 NO3. And now we have 2 sodium, 2 sodium, 2 NO3s, 2 NO3. We have 2 silvers and 1 sulfur. So now we're balanced. We're good to go. So if we look at this, now the question is, what we're learning about today, is this soluble? Is AgS soluble? And what we do is we look at our chart here, and we look at AgS. So if we look at our positive cation, which would be Ag, and we look through here, Ag here with chlorine or bromine or iodine, any of these, it would not be. If we look down here, we see sulfide S2, alkali metals or NH4 are soluble. So what we need to do is we need to look at our chart here, and we look at our alkali metals. That's lithium, sodium, potassium, rubidium, cesium, and francium. These are our alkali metals. That's not silver. Silver is over here, so that's not going to be. So if we look at beryllium, magnesium, calcium, all of these are not silver, so any other cation is not soluble. So we would look at silver, and we would see not soluble. And then on the other side, we have NO3, nitrate, NO3. Any cation is soluble. So we would look here and see that any anion is soluble. And that's how we look at our metal activity or reactivity charts. No, I'm sorry, our solubility charts. We look at our next one. We have another one just to practice it for you. And we have beryllium chloride and sodium sulfide. If we look here and we see this, what's going to react? Ba is not going to react with Na because they're both positive, and same thing with chlorine and sulfide. They're not going to react because they're both negatives. So if they are going to react, we will have a an NaCl. So if we look here, again, I'm sorry for the writing, for some reason it's really horrible today. Our sulfate. We look at our chart, we look at polyatomic chart, it would be -2 for sulfate. And beryllium, what does that have? Barium, not beryllium, sorry. Barium would have 2 electrons to lose, so that would be a +2. So it would be a match made in heaven there. And sodium, if we look at the periodic table, I think you already know the answer to this, but sodium is a +1 and chlorine is a -1. So we have a +1 and -1, and so this is balanced. Now the question is, are they soluble in water? If we look at here, And we have BaSO4. We have SA4 down here. Ba's here, not soluble. So we have this, not soluble. And NaCl, I think you already know the answer to this. So, but let's look it up anyway. And what we have is we have alkali metal ions Na, and any anion is soluble. So this is soluble, and we know this basically already because when we put sodium chloride, we've done it in class, into water, it's soluble. So that's how you use the solubility of some polyatomic or some ionic compounds in water, or solubility of ionic compounds in water, to see if they're soluble or not. So you need to be able to break down what's going to bond, what are the possibilities of the products, and then to see if they're soluble or not. Now, if these were multiple ions, if these metals could form multiple ions, you'd have to look at that, and you'd have multiple chances, and you would have to check possibilities of products, and then you'd have to check the chart. You would also need to balance these equations. So I didn't do that. NaCl, we need 2 because we have 2 over here, 1 SA4, 1 Ba, and now it's balanced. There you go. That is solubility of ionic compounds in water. I will post a Google form for you. Have a good day and stay safe.